This video is a beginner's guide to using measures versus calculated columns in Microsoft Power BI Desktop. Measures and calculated columns are the two ways provided in Power BI that enable you to perform calculations across your data. They're there for different reasons. Firstly, let me give you a simple rule of thumb. If what you're trying to do is perform summary calculations across your data, for example, total sales last month, use measures. However, if you're looking at a table of your data and you want an extra column in that table and every row of that column populated by a value, then use calculated columns, especially if you want those values to be used in further calculations later on. Let me show you this by example. On my right, I have a data set which is my Sage 50 accounts data pulled into Power BI Desktop using the Santigo BI connector for Sage 50 accounts. I have a table in this data set called product sales. And effectively what this is a list of all the line items of sales from all my sales invoices within Sage 50, plus a few extra fields. Let's take a quick look at some of that data. Firstly, if I select date, and I will choose the simple date format rather than the date hierarchy. Let's add product ID. And what I have now is a list of products that were sold on particular dates. Let me add my sales value. So that is my total sales by product by date. Now, actually what I want to do is I want to calculate the margin of my sales. So for that, I need my cost values. Now, what I have in my table is a unit cost value. So let's add that. But of course, I might be selling in multiple quantities, so I need to add quantity as well. Now, the next value I need is the extended cost. That is the unit cost times quantity. Now, I want to calculate this across the entire table. So I use, according to my rule of thumb, I use a calculated column. So let's add that now. I select new column. And let's call it extended cost column. And this is simply unit cost times quantity. Now, if you look at my data set, I can see that column here, and I can just add that to my visualization. Now, my margin is my sales value minus my extended cost. And again, I want to calculate this for each row of my table. So therefore, I will need a calculated column according to my rule of thumb. I will call this column margin column. That is simply sales minus my extended cost. That column is now in my table, and I can just add it to my visualization. And a quick look at those numbers and they look okay. I have sales of 2.64 minus an extended cost of 1.92 gives me a margin of 0.72. So far, so good. But actually, what I also want is a margin as a percentage. Now, margin as a percentage would be my total margin divided by my total sales expressed as a percentage. So let's try doing that using calculated columns again. And let's see what happens. I'll call this margin percentage column. Now, I will use the safe divide function that's available in Power BI, which enables me to handle the difficult situations if I have a zero denominator. That function is called divide. And I enter the numerator. My margin percentage calculation will be my sum of my margin divided by my sum of my sales. So let's do sum of margin. My numerator, and my denominator will be my sum of sales. And I need to tell the formula what to do in the event of a zero denominator. In this case, I want to leave it blank. And there's my calculation done. But I don't want it expressed as a decimal fraction. I want it expressed as a percentage. So I just select the formatting option there as a percentage. And now I can look at my margin percent in my table. Now that looks a little odd to me. If I sort this in descending order, what I can see is I've got some kind of crazy percentage numbers here which don't really make sense. I can see I've got, if we take this first value, first row, I've got a sales value of 33,647 and a cost of 24,390, but a margin of 428.19%. So what's going on there? Well, perhaps to give a few clues, let's just try removing the product ID from the table and see what happens. And here we can see straight away we've got an even bigger problem. If we look at the sales value on the 30th of September 2015, I've got 53,127. I've got a cost of 40,820, and it's telling me I have a margin of 4,642.53%. Now, to understand what's going on here, you have to understand the way the calculator column has worked, because it has actually done what I've asked it to do, but it's calculated my margin as a percentage for each row of this table. But what I've done is I've summarized this table by date. So I'm actually just looking at the total values by date. So it's adding up my sales value correctly, my total values for the 30th of September 2015 were 53,000. But what it's done is it's added up my percentage margin for each row of the table and added it all up to over 4,000%. Now, that's not the answer I want. Now, let's take a look at what would happen if we did the same calculation using a measure which is designed for use with summaries. Copy the formula and create a new measure. I call this margin percentage measure. I'll format it as a percentage. And I will add it to my visualization. I'll just pop that out for maximum view. And we can see straight away we've got a different answer in the table. We're looking at summary. We're looking at a summary of sales by date. Now, the measure is automatically taking this into account because the way a measure works is it performs the calculation based on the context of the visualization. A measure is not calculated before the visualization. It's calculated at the time of rendering the visualization, and it automatically takes into account all the filters and the context. So the measure takes the sum of sales by date, the sum of margin by date, and calculates the margin based on that as a percentage and gives me the right answer. You might ask, well, why don't I always use measures to do my calculations? And if you're working with a relatively small data set and not performing particularly complicated calculations, then that's perfectly valid. But one of the things you should take into account is the fact that the measures are calculated on the fly at the time of the visualization. So if you have a very large data set and you are performing quite complex calculations, perhaps calculations upon calculations. In fact, that's what we've done here because we've taken unit cost, we've calculated extended cost, then we've calculated margin, and then we've calculated margin percentage on top of that. These are all calculations that have to be done on the fly at the time of the visualization. So one of the things you would see if your data set is too large or your calculations are too complex is as you try and render the visualization, you'd get a lot of wheels spinning as the visualization tries to render itself. To avoid that, if you use calculated columns to perform the base level calculations, in other words, to create the basic building block fields for the rest of your calculations and summaries, and then use measures to perform the summaries on top of that, then you'll get consistently good results, and you'll also get better performance than exclusively using measures. So back to our rule of thumb. If you're performing data summaries, maybe you just want one value out of an entire table, which gives you your total sales last month. Use measures. If you need to create additional base level data that is then used in additional calculations later on, use calculated columns.